Welcome to the Cow Corporation's series of videos about software engineering. The topic of this video is using a semaphore to order code fragments. Before proceeding, make sure that you have already watched these other videos first. Because of its lack of ownership, a semaphore can be a good tool for ordering the execution of code fragments that are in different threads. For example, this before thread has a code fragment that must be done before the code fragment that's in this after thread. In this case, the semaphore's resource is not a physical thing, not like a phone line. The resource is the permission to perform the code fragment that's in the after thread. Use a binary semaphore to synchronize this multi-threaded program. Like any binary semaphore, its resource count can be either 0 or 1. But in this case, start out that count at 0, because initially the after thread shouldn't yet have that permission. After the before thread is done with its work, it will call the increment count resource, which essentially will be granting the permission. The previous example can be extended to the non-binary case, where there are multiple threads, in this case 3, that are all waiting for permission to start. One of our previous videos presented the dining philosophers problem. We will now use semaphores in a deadlock-free solution to that dining philosophers problem, where each philosopher is described as a thread. That philosopher thread wants to eat, but like our after threads of the previous example, it must first get permission. We'll use a binary semaphore whose resource represents that permission. We'll have one such binary semaphore for each philosopher thread. The permission to eat is granted once that philosopher thread has his chopsticks. Each philosopher thread attempts to play the role of the before thread, granting permission to itself. However, that philosopher thread will not succeed in granting permission to itself if either of its neighbors already have that chopstick that's between them. These state variables can be accessed by multiple threads, so we need to be careful to protect access to them by using a lock synchronization primitive. Not all threads will have succeeded in granting themselves permission. For those other cases, a thread will need to act as the before thread for its neighbors after it's been eating and is now done with the chopsticks.